So A is 3, 2, 6, negative 3. Okay. If I want to work out the determinant of this, I showed you this notation where we put absolute value signs each side of the matrix. Okay. Another notation which you may often see, particularly if you've already given this a name, so for example this matrix is called A, I could write as det of A. Okay, so it's like det, det, determinant, of my matrix A. Okay, so how would I work this out? What would this be equal to?
It's minus 21.
Good, because you get 3 times negative 3 minus 2 times 6. All right, so negative 9 minus 12 is negative 21. Okay.
It doesn't mean that what it was a square. It started to be 21 times little.
Yeah, exactly. I mean, actually, this type of transformation is not as easy as just an enlargement. There's kind of a shear going on as well. But yeah, it's a good question. So what does the negative mean? Like, we're happy that positive means it's 21 times bigger, like the area is 21 times bigger. But what do you think the negative means? Well, that would be, well, what would then half mean? So you're saying, why can't it be getting smaller? Okay, I think halves and thirds and quarters, like fractions, are pretty much reserved for that, or numbers less than 1. So what does negative mean? Can anybody think?
Negative is opposite.
Yeah, good. It's kind of been in the opposite direction. Okay, so it's getting 21 times bigger, but in the opposite direction. Does that make sense? Yeah. Okay, good. And yeah, you can kind of see that with that negative creeping in there. If you imagine that J is moving now 3 steps down as well. It's kind of been a reflection, kind of something like that happening.
But when we do exercise something like this, we just need to show it like this.
Yeah, this is all I need to show. So if I say find the determinant of this matrix, that's all you need. But obviously I've tried to give you a little bit of context. Like I've tried to say, this is what's actually happening here. I'm talking about areas which are happening here. Otherwise it's just a process, and learning processes in maths is boring, right? Okay, good. What about the determinant of B then? Okay, good. How did you work it out? 8 times 0 minus negative 5 times 10. Good. 8 times 0 is 0. Take away negative 50 becomes positive 50. Okay, so it's been made 50 times bigger. Good. What was the determinant of C? How do you calculate that? So you get 4 times 5 minus 10 times 2. So 4 times 5 is 20. Take away 20, comes out 0. Now pause a second again. Pause a second again. You're happy negative means it's still getting bigger, so negative 21 means it's still getting bigger, but in the opposite direction. So you're happy with working with negative determinants. What does a determinant of 0 mean?
Nothing changed.
Nothing's changed? Well, wouldn't that be a determinant of 1? Because a determinant of 1 would mean that the scale factor of the area would just be the same.
0, it was deleted.
You're not far off there, actually. So actually, if you plug this transformation matrix in, what you would find is that your shape, which was looking something like this, okay, would effectively be collapsed. It will basically be reduced to just be on a single line. So in other words, I and J are kind of being moved onto a straight line, okay, being moved onto a straight line. So effectively, is no shape there anymore. It's just been collapsed into a single dimension. It's taken from a 2-dimensional object, up and down, left and right, and it's been collapsed just into a single dimension. Okay, so it has no area. Area has no meaning in 1 dimensions. Okay, so yeah, if you're interested in what that means, that's literally what it is. By the way, go and play around with the GeoGebra thing, which I showed you on Wednesday, and you'll see this happening. Okay, but fine, just for the sake of speed, let's carry on. What's the determinant of this? Okay, I'll just write down the answers then. So yeah, negative 1, do you agree with that? Yep. So you're happy it's the same size, just in the opposite direction now. What's the determinant of E? Negative 28, good. What's the determinant of F? 16? 61. Okay, good. What is the determinant of G? 0, yeah, good. So again, this has been collapsed into a single straight line. Okay. I might show you what this means and what this means in the context of GeoGebra on Monday, but for the meanwhile, are you happy just with the calculation? Yep.